Hi, everyone. I'm Daniel, and welcome to yet another episode of the Light Your Candle podcast. The question I want to pose to you today is, have you ever wondered what makes a sunset so beautiful? What is it that causes the emergence of all the rich, vibrant colors that we know and associate so well with a sunset? We know light from the sun is made up of all the colors in the rainbow. In fact, it's made up of much more than that. There's also ultraviolet and infrared and radio waves and many other parts. The light we can see with our eyes, however, is referred to as visible light. That's the rainbow. We're going to restrict our discussion to the visible part today. Each color corresponds to a particular frequency vibration. Red light is on the low frequency end, and blue light is on the high frequency end. You can think of colors as different musical notes. But instead of sound, the medium is light. In this case, red is a low note, say a C, and blue would be a high note, let's say the C an octave above. With all the notes in between being all the other colors of the rainbow. Now, that frequency difference is why we see the rainbow in the first place, as the different colors bend differently as they pass through raindrops during a storm. Now, really quick, I want to make a quick tangent and ask another question. Have you ever wondered why the sky is blue? And no, it's not because it's the reflection of the ocean. It turns out the reason the sky is blue is because when the light from the sun hits the Earth's atmosphere, hits the air, the bluer frequencies in the light get scattered more by the atoms in the air than the lower frequencies, than the reds and oranges. In other words, the bluer frequencies are more likely to hit an atom, and bounce off in a different direction. That's why on a clear day, wherever you look in the sky, all you see is blue. So then, why all the reds, oranges, and yellows at sunset? For this, we need to think about where the sun is at midday versus where the sun is just before sunset. See, at midday, the sun is directly above us. So the sunlight has to only travel a short distance through the air to reach us. For scale, the thickness of the atmosphere is about the thickness of the skin of an apple to the apple itself. I'll let that little part sink in for a bit. The atmosphere is only as thick as the skin of an apple, where the earth is the apple itself. I'll also notice there are a lot of apple analogies going around. The apple is sort of a sacred fruit in physics, so it's going to show up a lot. However, at sunset, the sun is now no longer directly overhead. The Earth has spun away from the sun, so there is now more atmosphere that the sunlight has to pass through before it reaches us. And because the atmosphere scatters blue light more, by the time the sunlight reaches us, all that blue light has been scattered away, leaving behind only the yellows, oranges, and reds, those other parts of the rainbow. An example I want to give you, an analogy, is we've all been kept up by neighbors having a party next door, right? We hear the music coming through the walls. It's really annoying. We're trying to get some sleep. Which part of the music do you hear the strongest? The bass, right? That's because the higher frequencies have been scattered away by the air and the walls and the concrete. they've all been taken away, scattered away by the time the music actually hits your ear. And the base in this example are the gorgeous reds and oranges we see at sunset. In fact, next time you catch a sunset and you're admiring the beautiful deep oranges and reds, think about the fact that someone else in a different part of the world could be seeing the blue that got lost on the way from the sun to your eyes. That begs the question, though. Why then do we find sunsets so beautiful? I would say because they look like sunrises. And that might sound like slightly circular reasoning, but hear me out here. The next question would be, why then do we find sunrises beautiful? And for that, I want to take us back a few tens of thousands, even hundreds of thousands of years, to a time before humans had mastered the power of fire. Allow me to set the scene. It's nighttime. A very different experience for those people. You don't know the Earth orbits the sun. You don't even know the Earth rotates at all. You probably worship the sun as a god, and that makes sense. It provides warmth, it allows the crops to grow, it illuminates the world. Yet for reasons, perhaps claimed to be known by certain people in your tribe, the sun, after spending a certain amount of time in the sky, disappears. In doing so, the world is plunged into darkness. It gets very cold, and unless the moon is up and close to full, you can barely see anything. The risk of being attacked by some animal or some other predator, including another person, is much higher. Worst of all, you probably believe your god has just lost some epic battle, and there's no guarantee he or she is going to come back. Have no doubt, nighttime would have been an incredibly scary and stressful time for early humans. But then do you know what happens? After hours of being tormented by the cold, by the ever-present fear that there is something lurking out there in the wild, just waiting to eat you or one of your loved ones, suddenly, the light begins to return. You realize that your God, the source of all divine goodness, is returning to the world, bringing warmth and safety with it, including all the colors of the sunrise to mark its triumphant return. So why do we find sunrises beautiful? Think about it next time you're outside and looking at the sun. Generation after generation who lived in fear of the night would quite literally thank God every morning when the sun reappeared. Perhaps it's a reaction engraved into the very neuroanatomy of our species. One final note about sunrises. We all know that it's colder when the sun is down than when it's up. That begs the question, when is the coldest time of day? You might think it's just before the sun rises, right? The night is darkest before the dawn kind of thing. Well, that actually isn't the case. The coldest part of the day is actually just after the sun rises. This is because even though the sun is up, the Earth is still losing more heat than it's gaining from the sun, as the heat hasn't quite made its way all the way through the atmosphere yet. Counterintuitive, isn't it? This parallels life, I think. It can often feel as if the night will never end. And even when the light in the sky reappears, the final stretch is often the most difficult, the most testing. But if you just hold on, Realize that it was always going to get worse before it got better. It was always going to get colder before it got warmer. I promise you will feel the sun's warmth on your face again. So until next time, take care of each other.